Welcome viewers. Today we are going to see how we are going to compile and upload the code on an ESP32 board of our own design. Some preconditions are required. So we are not going to talk about how we are going to install Linux on the Windows and how we are going to set up the development environment, as this is another separate topic. This can easily be found on the GitHub repository of Ardupilot. So let's start by downloading the GitHub repository of Ardupilot first. So the easiest way to do is go to the GitHub website, to the Ardupilot, copy the link of the code, open the Linux terminal under Windows, and just use git clone command and then paste the link that you've just copied. This will start downloading the Ardupilot repository to your hard disk. It's going to take some time depending on your network speed. So we are going to speed it up here. Okay, so now we have downloaded the Ardupilot repository. Let's look at the repository. The first thing I will advise is to go and look at the README file. This is a wealth of information. So one README file is for the Ardupilot repository, but the one we are more interested in is the ESP32 related README file. So you go to the libraries folder under Ardupilot, go to AP-HAL ESP32, and here you will find another README file which is specific to the ESP32 environment. So this ESP32 README file basically gives you everything that you need to do to compile the code on an ESP32 board of your own design. The compiling commands, as well as the pin definitions, the different details regarding the ESP32 environment is all given here. I highly encourage you to read this README file, as everything that I know also comes from exactly same source. So I've just gone through the README file and figured out how to compile and install the Ardupilot code on my ESP32 board. Here it shows you what is the current progress and what is remaining. So a lot of details in this README file. Now the section that I am highlighting, this is essentially all the commands that you need to run under Linux to compile your own Ardupilot code. That is it, the highlighted part. So to make things easier, I've actually copied and made another text file where I pasted these commands. Now you can essentially just copy this command and paste it into the Linux terminal to run it. So you don't even have to type these commands. So here you can see I'll just select some commands and paste them in the Linux terminal and they will execute. So it cannot get easier than this. You don't even have to type them. You just copy and paste them from the README file and it executes it. It executes it in order, and there is no syntax error mistakes as well. Now first time you run it, because it includes some submodule updates, so it's going to take some time. But once you've run it once and then you're going to do maybe make some changes in your firmware and want to run these commands again, it will be much faster because the updates mostly are complete, and between the two consecutive runs. If you are doing it after a few days, the updates required will be very small and will not take much of the time. So again, we are going to speed up this process. So in reality, it might be a little longer, but here we are just going to speed it up. So the commands that I'm running, they are basically updating the system to the latest submodules, setting up the environment. So this I've copied as a group. So that's what it's doing right now. The next set of commands is actually going to configure and compile the code for ESP32. So that we will do in the next step. All right, so that's done. So we can run the next set of commands. Similar procedure, just copy paste. It's done quickly. Okay, now we go to the WAF configure, which will configure the WAF environment. It doesn't take long usually. It's fairly quick. Now the next set of command is going to configure it for our board. So you can see we have selected ESP32 bus board here, and I'll come to that in a minute. So we'll configure the WAF for the board, and now the last command is going to compile the whole code for the copter, which is going to be a Ardupilot branch of this code configured for our board. Later on in the mission planner, we can select what type of copter is this. Is this a quadcopter, a hexacopter, or different configurations that are available with Ardupilot. But the same copter code works for all of them. So we only need to compile it for copter. Similarly, if you are doing it for an airplane, you can compile the code for plane. Again, we've sped it up because this process sometimes takes long. And now it's generating an ELF file. Right, so the code is written. So this process will generate 3 files which we will require to update to upload to our ESP32 board. So the main code is the ardupilot.bin file, which I have highlighted. The next one is the bootloader.bin, which obviously, as the name suggests, is a bootloader file. And the third one is going to be the partition table.bin file. So we require these 3 files to upload to the ESP32 module to successfully run the Ardupilot code. All right, so let's see where this code will be uploaded. So if you go to Ardupilot, all these files are under build environment. Here we have seen ESP32 bus, which was our board, ESP IDF build, where it is, bootloader. So now we have this one, bootloader.bin file, as we saw in our messages. We go back to partition table, and here we find the partition table.bin file, which we also saw in our messages. And then the third will be the ardupilot.bin, which is the main file. So we have all the 3 files. Now we need to know where in the memory we are going to load these files. It is also given in the same folder, flash_arguments. It's a text file. You can open it with Notepad Notepad or WordPad, whatever program you like. And here we have it. So you can see the bootloader.bin is going to be written at address 0x1000, Ardupilot.bin at 0x10000, and partition table.bin at 0x8000. All right, let's look at how we are going to upload the code to ESP32. For this, we will need a program called Flash Download Tool. This is from Espressif. As you can see, we can go to the Espressif site and go to the Flash Download Tools link. Now this will open a website which will show you the tool user guide, all the details, which is fairly useful information here. It shows you the user interface and all the options that are available with this tool. You can look at this site as well, and then we go straight away, just download the Flash Download Tool. It's a small program. It's not required to be installed. You can run it straight from the folder after unzipping it. That's what we will do. So here I have unzipped into my D drive, and let's go ahead and run the program. So once you run it, it asks you what type of ESP32 boards you have. Oh, but before that, okay, so Windows is going to flag it, so you got to run it anyway. All right, so here, yeah, it says what type of chip type do you have? ESP8266, ESP32, ESP32 different versions. So I just go with ESP32. That's what I have, the dev kit. So now here you have the main window where we are going to download it. The user interface is not the best. I cannot get the file names to show fully on it. So I don't know, I'm doing something wrong. Maybe if you figure it out, let me know. So we'll select each file, each of the 3 files that we have for uploading. So let's say, and the order is not important. So here I have the first one, ardupilot.bin. Then I go to the next one, bootloader.bin. And then I go to the third one, which is the partition table.bin. In the next column, I need to give the addresses to which it will be uploaded. So we go, ardupilot.bin was the first one, so it's 0x10000. So the next one is bootloader, so that's 0x1000, and third is the partition table, so 0x8000. You have to type 0x with the x address. And then you have to make sure you select all these 3. Now we need to upload them. We can simply do start, so com has failed, so I need to go. I was working on it before, so I have some other maybe programs open which are using the COM board. Okay. Yeah, I have the mission planner open for another board. Okay. So now once you've selected the COM, just do start, and once it shows the AP and station MAC addresses, you know that it has communicated to the ESP32, and now it starts uploading it. So here it's slightly different because even though it's Ardupilot, it's not built and compiled under Arduino platform. It's a separate WAF environments, and the files generated are also not exactly under Arduino. You will generate a single bin file. Here you have a bin file, a partition table, and a bootloader bin file. So it takes a little while to upload, but it will go through. Alright, so we successfully uploaded the program. Now we can go to the mission planner, which you can download from the internet. Just select the right COM port, assuming that you are connected to the board with a USB to serial, or if you are connected to the dev kit, you can directly connect to USB and select a COM port. And then once you do connect, you can see that it will start communicating with the board. It's getting parameters. Now, if your board definition is correct, all the readings will start showing up, and your accelerometer, gyros, compass will have some readings, and you will see the correct readings here. Then there's a bunch of setup stuff that you need to do here. You have to set up the frame type, whether that's it's a quadcopter, hexacopter, octacopter, and etc. And then you have to calibrate the sensors, but that's a completely different topic, where once you have installed the Ardupilot on your ESP32, you need to go through the calibration and setup of that board. One thing I will mention though here is that the Ardupilot running on ESP32 does not run at 400 Hertz loop rate. So that you need to be careful with. I don't know if it is a limitation with ESP32 or it's a limitation with the code compilation, but basically by default Ardupilot is required to run at 400 by default, but you can change it. So you can go to the detail parameter or full parameter list, and you can see the scheduled loop rate, and you can reduce it from 400 down to 100 Hertz or even 50 Hertz. You have to do that because under ESP32, in my experience, Ardupilot does not run at 400 Hertz. So your calibration for your PID loops will not work correctly because the ESP32 is not running at 400 Hertz. So you have to set it correctly to run at 100 Hertz first, and then go and do your PID tuning. Now let's see how we customize this code to our ESP32 board. So you go back to the Ardupilot repository, go to the libraries folder, go to epihal ESP32, and here you will find the boards folder. So this boards folder is where the board definitions are stored. So the easiest way, like we compiled it for ESP32 bus, what I did was I copied the original ESP32 bus in the and renamed it, and then opened the ESP32 bus and changed it according to how my board connections were. So all your hardware connections, the accelerometer, gyro, barometer sensor and magnetometer, everything is defined here. Now one thing I will say that you can actually create your own file, but it requires more changes in different folders. So the easiest way is just take one of the existing file and update it according to your connection. So here you can see the INS choice that I'm using is ICM20948 and it's under SPI. Then I am also saying for compass I'm using the same ICM20948. For barometer choice, you can see I have a BMP280 which is connected to I2C. It's not on SPI. Then again, by default, if the barometer is not present, the system will not boot. But here we have set it that the boot without the barometer is allowed. Here's the pin definitions for ADC. Here's the Wi-Fi SSID and password for the Ardupilot. So you can even connect it to this Ardupilot over Wi-Fi as it's built into the ESP32. Here you can see the RC out pins, and again depending on the number of pins on your board available, you can have RC out for 6 or 8 or 10, whatever you have the pins available. Now here we are defining the SPI buses, that what pins are used for SPI bus. And then we are also defining the SPI devices. So I'm defining one device which is ICM20948, which chip select pin it is using, which is pin number 5. And then I'm also defining the I2C buses because as ESP32 is configurable, so I'm saying pin number 17 and 16 are used for serial data and serial clock of I2C bus. So essentially this hardware definition file is where you will have the definition of your board, and this is the file that you need to configure to match your board to the Ardupilot firmware. Now there's a bunch of files in the same folder. ESP32 bus is one of them. So I will encourage you to go through each of them, and then you will figure out how to connect different sensors to different buses, and you can define multiple buses. So you can have more than one SPI bus, you can have more than one I2C bus, you can have multiple serial ports. As you can see here, there are 3 serial ports that I have defined. And the serial port numbering is also a little bit particular. In this file you will define UART number 0, 1 and 2, but in the mission planner they will show up as different. So UART 0 is serial 0 for the Mavlink. UART 1 actually shows up as serial 3 in mission planner, and UART 2 shows up as serial 2 in mission planner. So serial 1 actually shows up under Wi-Fi. So when you are connecting optical flow sensor or GPS to the serial port, you need to know what is the exact name of that serial port. So here you can see some of the other files. So this is all which comes default with the Ardupilot repository, and all these files show you different sensors and connecting them to different pins. So you can mix and match, you can copy code from one and build your own custom hardware definition file. Even there is one for ESP32S3. So if you have an ESP32S3, which is a newer one, you can use it. And then there's ESP32 NIC, ESP32 Icarus. All these have slightly different setups for sensors and ports. Again, I will say that it's easier to just take one of these files and modify it and use it. You can create your own custom file, but you will have to go to some other places to define those files, because uh, not only that these board definition files are under boards folder, under ESP32 HAL, also there are some places where these files need to be defined. Overall, these are fairly self-explanatory. I will copy the files that I have used in the GitHub repository, and you're free to use it. You're most welcome to use it. You're welcome to change and change them according to your own board setups.